Hello, welcome back. Now we're going to dive into chapter 2 of our Learning the Calculus Without Knowing Calculus. In chapter 1, we figured out that calculus is not just some terrifying equation, that calculus is not just some scary symbols, it's not some equation that you have to solve to pass your exams. We figured out that calculus is common sense that you do every day. Now we're going to start mastering the grammar and the words and this whole world of calculus. Before we go into chapter 2, where we're going to talk about growth, let's recap and refresh where we left off. We learned our first sentence of calculus grammar, where we said y is equal to c f x, where we said that for every action, our independent variable x, there is a result, the dependent variable y, which is controlled by growth factor c. That was our basic form of the rules of the equations of the rules of the system. We defined a very simple equation. Then we learned two basic words of calculus, again the building blocks of calculus. Differentiation, where differentiation was the rate of change or the pulse of the system, that how fast or slow the system is changing. Then we learned that when we add up all the changes that have happened over a period of time or a period of action that you have taken up, they add up to the reach or the accumulation, and we said that is our integration. Now let's look at our chapter 2, where we're going to talk about growth. The reality of the world is that growth is not always same. The growth can happen in different shapes. The growth can take different patterns. It's not here we are just looking at two very basic types of growth. One is our steady growth, where for the amount of action that we are taking place, the system is growing or the change is happening at the same rate. That is our steady growth. Then we are looking on the right, that is our wild, you can call it a wildfire growth or a viral growth, where the system is initially changing slowly and then it picks up. On this slide, we're only looking at two shapes. That does not mean that the growth only happens in only two forms. There are more, and that is this chapter is all about, where we're going to learn about what are the different types of growth that happen. Let's look at our first one, the flat growth. The word flat pretty much defines it, that the growth is there is no growth. This is defined by a simple equation, y equals c, where if you remember, y is our result and c was our growth factor. If you look at it, there is no x or the independent variable. What that means is that no matter what we do, what kind of action that is taking place, whatever the kind of change that is happening, the result is not going to change. And that is what is shown in this curve also, that over the period of this whole action x, the result y is always the same. It is steady. It's not even growth. That simply means that the result is always going to be same. Think of an example of a climate controlled room. Let's say that you set the thermostat at 72 degrees Fahrenheit. So it doesn't matter what's happening outside. If you have to plot the temperature of the room over a period of time, it is always going to be at 72. Next example is, let's say, a steady heart rate. Yes, in reality, the heart rate is always changing, but think about it, that if you really have a steady heart rate and it is set at 60, let's say a person who is sleeping in a very deep sleep, the heart rate is always kind of beating at the same. And if it is 60, then you can see that over a period of time, if you have to plot the heartbeat, it is always 60. That is our first type of growth, the flat growth. Next growth that we see is called the steady growth. The word steady meaning that the growth is happening at the same rate all the time, or it is a constant pulse. It's a constant change that is happening. It is defined by a mathematical rule or your equation, where y is equal to cx. Y is our dependent variable, x is our independent variable, that means the action, and c is our growth factor. Let's take the example of our video viral, or the video that we have posted. So if you look at the numbers here, you can see that over a period of time, at 30-minute mark, you have 200. At 60-minute mark, you have 400. That means this is the unit of action that is taking place that is set to 30. So for every 30 minutes, you can see that first it was 200. Then in the next 30, the growth is 200. Then in the next, the growth is 200. Again, the growth is 200. That means the change is very steady. And that is what is called the steady growth of change. The next one is the exponential growth, or you can call it the viral growth. Before we discuss the growth, let's look at the word, the sentence itself, y is equal to cx, meaning now we're using the exponent. Exponent comes from a Greek word which means to put forth power or to exhibit its power, or you can say exert its power. If you look at, if we have to explain this, what this really means is that now we are saying is that in the previous where the growth was steady, we said that y is equal to c into x, where the action and the results, they are at the same level, or you can say that they are at the ground level, that the result and the growth is moving on at the same baseline. What has happened in this exponential growth, your action has gone to a floor up. What this tells is that how many times your constant factor c needs to be multiplied by itself. That depends on x. So if you look at your video, the growth example, our unit of movement was 30 minutes. So if we have to use a constant of c, that means the number is going to double with every single step we are taking. So your growth is not standing on the ground floor, it has actually raised one floor up. The other way to look at this type of growth is that the bigger the results get, the faster it breathes, the faster it grows, and that is the accelerating growth. Let's look at the numbers. So again, we are taking the example of our video post that we did. So if we look at is that from 0 to 30, meaning the first 30 minutes, we have total views of 200. The growth is 200. Then in the next 30 minutes, now we have total views of 400. The growth is 200 because it is slowly picking up. Now this growth starts accelerating. In the next 30 minutes, now you can see that the number of views have doubled from what was before. 400 becomes 800. The growth is now to 400. Now if we go to 120, you can see that it has gone from 800 to 1600. So you can see that the growth has jumped from 400 to 800. Take another 30 minutes, the growth has jumped from 800 to 1600. Your total views is 3200. And if this trend continues, you can just call it a wildfire, or it is your viral growth that is happening, or the pulse is getting faster and faster. Let's look at the fourth type of growth, the logarithmic growth, or you can call it a tapering pulse. To imagine this, think about the video that you have posted. You start getting views initially, and the number of views are not going to keep increasing. The natural trend is that first it will increase and eventually it will start flattening out. That means the growth is tapering. So initially the growth was faster, but eventually as the number of your subscribers, your viewers, you have exhausted, now the views are also going to start tapering out. Means you're going to reach a saturation, that the videos will be growing, but they will be growing at a very slow rate, and eventually it may just come to a standstill. Means it's a tapering kind of growth that is happening. If we have to look at the numbers, this may explain this a little bit better. Let's take the same examples that we have for our video that we posted. We're going to start with our baseline that for the first 30 minutes, we have 200 views. Now another 30 minutes pass, we have 400 views. It's the same thing that we have seen in the previous one, in the steady growth as well as the exponential growth. But now the third unit that takes place, you can see that now the time has jumped from 220 minutes. The growth is still 200, but it has taken additional 30 minutes. This is what the key is, that it's taking additional 30 minutes to even get 200. Let's take the next one. Now you can see that it's taken another 120 minutes to get another 200 growth. Means it's taking longer and longer to get to the point of the same growth level that we had. Now it's taking another 4 minutes to actually gain the next 200. So you can see that initially it was faster, and then it is now slowing down, and eventually it will just flat, meaning that it starts faster and then it starts tapering off. That is why you can call it a fading momentum. You can call it tapering pulse. So these are the four growths, the basic growths that have. So to summarize this, these are the four very basic shapes of growth that take place. Stopped pulse, where the system is just not growing. No matter what the action is taking place, the result is locked in place. It's always going to be same. Then you have the steady pulse, where the rate of change is constant. The progress follows a straight line. Accelerating pulse, where the system is feeding on itself. The growth is accelerating. Then you have the tapering pulse, where the system grows faster first and then it starts slowing down or tapering off. So by looking at the pulse or the rate of change, you can kind of figure out that what kind of growth that is going to happen. So this is what we have in this chapter, where we talked about the shapes of growth. And in the next chapter, we will talk about more about the world of calculus. Thank you so much for watching. And if you have liked, subscribe to our channel, visit our website for more information. Till next chapter, till next time, take care. Goodbye.